Hello everyone, welcome to today's class. We will learn about the operation of reciprocating pumps. Before studying the operating procedures of reciprocating pumps, it is necessary to first understand their structure, working principles, characteristics, and flow regulation methods. First, let's look at the structure of a reciprocating pump. As shown in the diagram, the main components include the pump cylinder, the piston rod, the suction valve, and the discharge valve. Both the suction and discharge valves are check valves. The working principle of a reciprocating pump includes two aspects: liquid suction and liquid discharge. The liquid suction process of a reciprocating pump is as follows. When the piston moves from left to right, the volume of the working chamber increases and the pressure decreases. The suction valve opens under the pressure difference between the inside and outside, allowing liquid to be sucked into the pump. The liquid discharge process of a reciprocating pump is as follows. When the piston moves from right to left, the volume of the working chamber decreases and the pressure increases. The discharge valve opens under the pressure difference between the inside and outside, allowing liquid to be discharged from the pump. Reciprocating pumps have the following characteristics. First, flow irregularity. Due to the structure of reciprocating pumps, their instantaneous flow is irregular, especially in single-acting reciprocating pumps, which is more pronounced. Using multi-cylinder pumps is one way to improve flow uniformity. The instantaneous flow of a multi-cylinder pump is equal to the sum of the flows of all cylinders at the same instant. By appropriately positioning the cranks of each cylinder, the flow can be made more uniform. Second, flow consistency. Although the instantaneous flow of a reciprocating pump is irregular, the amount of liquid delivered within one working cycle is fixed, depending only on the piston area stroke and reciprocating frequency. The theoretical flow of a reciprocating pump is determined by the volume swept by the piston per unit time and is independent of the characteristics of the pipeline. Third, positive displacement of reciprocating pumps, because the liquid is discharged by squeezing. The head of a reciprocating pump can theoretically be arbitrarily high, as shown in the diagram. The discharge capacity of a reciprocating pump depends only on the pump itself and is independent of the pipeline conditions, whereas the head depends only on the pipeline conditions. This characteristic is called positive displacement, and pumps with this characteristic are called positive displacement pumps. Fourth, self-climbing ability of reciprocating pumps. Reciprocating pumps can draw air out of the pump and suction pipe by themselves, allowing liquid to be sucked into the pump from a low position, giving them self-priming ability. Common flow regulation methods for reciprocating pumps include the following three. First, bypass valve regulation. The pump's liquid delivery volume remains unchanged, but part of the discharged liquid is returned to the storage tank, causing a change in the flow rate in the main pipeline. Obviously, this regulation method is not economical and is only suitable for frequent adjustments with small flow rate variations. Second, changing the crankshaft speed. Since the motor is connected to the reciprocating pump through a reduction device, changing the transmission ratio of the reduction device can easily change the crankshaft speed, thereby changing the frequency of the piston's reciprocating motion and achieving flow regulation. Third, changing the piston stroke, changing the distance of the pistons, reciprocating motion. Next, we will watch a video on the operation of a reciprocating pump. Operation of a reciprocating pump. A reciprocating pump relies on the reciprocating motion of a piston or plunger inside the cylinder to change the volume and pressure of the working chamber, thereby transporting liquid. Its characteristics include small flow rate, cooled high head H, and self-priming capability. Now we will demonstrate the start-up and shutdown of a piston diaphragm pump. Start-up of a piston diaphragm pump. First, check the integrity of the anchor bolt connections for any looseness. Inspect the pipeline and pump body for abnormalities, and ensure the pressure gauge is intact. Second, check the oil level. First, the lubricating oil. Second, the oil on the piston top diaphragm. Third, perform a rotation check for the first startup. Rotate the motor fan blade. This is not required for subsequent startups. Fourth, open the pump's inlet and outlet valves and use the stroke adjustment handle to set the stroke to the 0 position. Fifth, start the motor. Ensure the pump outlet valve is fully open before starting the motor to prevent motor burnout due to excessive outlet pressure. Sixth, adjust the stroke to achieve the desired normal flow rate. When adjusting the stroke, avoid doing so too quickly or forcefully. Adjust from a small flow rate to a larger flow rate. If adjusting from a large flow rate to a smaller one, overshoot by a few notches and then adjust back to the desired scale. Seventh, observe the pump's inlet and outlet pressures. Eighth, listen for sounds and feel for vibrations. To check for any abnormal noises or vibrations. Ninth, after some time, check the motor temperature. Use the back of your hand to touch the motor when checking the temperature. At this point, the pump is in normal operation. Shutdown of a piston diaphragm pump. First, when shutting down, first use the stroke adjustment handle to set the stroke to the 0 position. Second, turn off the pump motor. Third, close the inlet and outlet valves. Fourth, open the drain valve to discharge any residual liquid from the pump. Through this lesson, we have mastered the structural working principles, characteristics, flow regulation methods, and start-up shutdown operations of reciprocating pumps. Now, we will consolidate the knowledge learned today through a few exercises.